Alrighty, welcome back. So we're still in that pre-security module. We're in how the web works. Now we're in the room of HTTP in detail. So this says it's easy. It should take about 30 minutes. We'll see. But we're going to learn about how you request content from a web server using the HTTP protocol. All right, there's a lot of good information here, a lot of fun stuff that if you like this and if you're into offensive stuff, oh boy, finding fun stuff on the web, this is your base foundation. All right, so like usual, it's going to start off with a video, 24 minutes. I would highly recommend watching that, but here we go right into it. So we're going to start off with what is HTTP slash what is HTTPS. So what is the Hypertext Transfer Protocol? So that's what's being used whenever you view a website, and it's developed by Tim Berners-Lee and his team between 1989 and 1991. HTTP is a set of rules used for communicating with web servers for the transmitting of web page data, whether that is HTML, images, videos, whatever. Anytime you're in that address bar and it starts with HTTP or HTTPS, hey, that's protocol that's being used. So HTTPS, the Hypertext Transfer Protocol Secure, well, think about that name. It's the secure version of HTTP. So HTTPS data is encrypted, so it not only stops people from seeing the data you're receiving and sending, but also gives you assurances that you're talking to the correct web server and not something impersonating it, which is pretty important nowadays with so many phishing attempts and everything. So let's go ahead and go straight into the questions. What does HTTP stand for? That is that Hypertext Transfer Protocol. And what does the S in HTTPS stand for? That's going to stand for secure because it's the secure version of it. It says on the mock web page, there's an issue. On the right, there is an issue. Once you found it, click on it. And what's the challenge flag? So let's go up here, launch view site. Hey, look, it's a website. And I'm pretty sure you guys are familiar with this. If you haven't, internet browsers nowadays like to protect you in certain ways, such as showing you when something is not properly secured. All right, so if we just go and drag this so you guys can see this. Alrighty, boom, look, there we go. Bam, that has a lock on it. This one does not. So that's probably what's wrong. Hey, we click on it, and now we have our flag. So let's go ahead and copy and paste that. Sweet, task one is done. So let's go ahead and shut that guy down. Alrighty, next up, requests and responses. So when we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access those resources. And this is where the URLs will help. So a URL is a uniform resource locator. If you use the internet, you know what URL is. The URL is predominantly an instruction on how to access a resource on the internet. The below image shows what URL looks like with all of its features, and it does not use all the features in every request. So we have the scheme, the user, host domain, a port, a path, a query string, a fragment. So these are all different parts of what can make up a URL. So the scheme, that instructs what protocol to use for accessing the resource. So it could be like HTTP, HTTPS, or the file transfer protocol, which is FTP. We could have a user. So some services require authentication to log in, and you could put username or password into the URL to log in. The host is a domain or IP address of the server that you wish to access. I mean, that's the most common thing that we think of when thinking of URLs. We're going to have our domain, typically there's a scheme, there's a domain, and it might just be, like .com or something like that. But going through, let's see, we're at port. So the port you're going to connect to, the two main ports that you're going to think about are HTTP is 80 and HTTPS is 443. All right, but this will be hosted on any port between 1 and 65,535. We went over this in a previous lesson, so it's good to see that information up. And again, we have a path right here, which could be the file name or location of the resources you are trying to access. A query string, so extra bits of information that be sent to the requested path. For example, blog ID equals 1 will tell you that the blog path you wish to receive is a blog article with the ID of 1. So you can start to manipulate that if you put a 5 there, and if they have a blog that corresponds as their 5th blog in that path, there you go, it will resolve to that. And we have fragment, which is a reference to a location on the actual page requested. So this is commonly used for pages with long content and can have certain parts of the page directly linked to it. So it's viewable to the user as soon as they access the page. In this case, it's saying, hey, for task 3. So if you look in TryHackMe stuff on their web pages for their rooms, we have task 1, task 2. This would probably resolve to the third task, which let's say it's that one, um, in a room with an ID of 1. So that's just an example of how that will work. So let's talk about actually making requests. So it's possible to make a request to a web server with just one line of get/http/1.1. All right, so this diagram, we have the request method. We have that, what we just said, the get HTTP 1.1, the HTTP protocol version, as well as a page being requested. So we don't really do that though. We like to give it a bit more information, and that's where it's going further down. So, but for a much richer web experience, you'll need to send other data as well. This other data is sent in what we call headers, where headers contain the extra information to give the web server you're communicating with. Yeah, so it just communicates more information. But we'll get more into that in the header tasks. So an example request, if we do get/http/1.1, host is tryhackme.com, the user agent is saying what you're using, which is Mozilla Firefox, it could be Google Chrome, Microsoft Edge, whatever, and the refer is going to be https tryhackme.com. So it's now breaking down what was in this request, which is going to be the get method right here. All right, we're going to go more into that in HTTP methods task, but that's the method, it's get, and it wants a request to the home page. That's what this / is about. Installing the web server, we're using this protocol of HTTP, not HTTPS, and it's version 1.1. We can tell the web server we want the website of tryhackme.com. We tell the web server we are using the Firefox browser version 87. And then this over here is the, what is it? The page that referred us to that is tryhackme.com. And then it's going to say line 5, HTTP requests always end with a blank line to inform the web server that the request has finished. All right. So if you mouse over it, there is a blank line there. Now let's look at a response that you could get. All right. So we have over here, HTTP 1.1, so it's that same protocol. It's a 200 status, and it says OK. It's giving you information on the server, the date, the content type, the length of it, and it is responding with the HTTP, or the HTML, sorry. So breaking it down, line 1 shows the version of the protocol, as well as the HTTP SAS code. 200 OK tells us that request was completed successfully. Line 2 tells us the web server, which is in NGINX server, and its version number. Line 3 is the date and time zone. Line 4 is a content type header. So it's going to tell you if it's giving you HTML, images, videos, PDFs, what have you, and it's giving us HTML. The content length itself is 98, so that's telling us how long the response is, and we should be able to verify that with 98. Line 6 is the blank. So we have a little blank right here too. And then the next lines is the actual information that's being requested. So let's go and answer these questions. What HTTP protocol is being used in the example above? That's going to be HTTP/1.1. All right. And we know that because our GET requests asked for the protocol of HTTP 1.1. And even the response confirmed it with HTTP/1.1. All right. And what is the response header? What response header tells the browser how much data to expect? So if we look at this in the response, we have first the protocol as well as the confirmation code, or what the status code, I'm sorry, the server name, data, content type, and content length. When we're talking about how much data we should be expecting, it's probably going to be this content length one. Let's see if that fits in there. Hey, well, you know, it does. Cool. Onto task 3, which is HTTP methods. All right, so HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods. We'll cover the most common ones. Um, and then it says you'll mostly deal with the get and post method. So a GET request. This is used for getting information from a web server. Very straightforward. All right. A POST request. This is used for submitting data to the web server and potentially creating new records. So if you're thinking about a website in terms of a database, where maybe there's a user account, something like that, or maybe it's a blog post, but creating new entries should be associated with POST requests, potentially. All right. A PUT request. This is used for submitting data to a web server to update information. So you're not making a new record, you're putting new information, you're updating existing records there. Then you have a delete request, which is used for deleting information or records from a web server. So we have 4 questions here, all right? What method would be used to create a new user account? All right. Between get, post, put, and delete, the post request deals with potentially creating new records, such as a new user account. All right, what method would be used to update your email address? All right, so if we're looking at these, we're not deleting it, we're not making a new one, we're not just asking for information, we want to update it, and that's going to be a put request. All right, so what method would be used to remove a picture you've uploaded to your account? We're not updating, we're not asking for anything. We want to delete that, all right? So we're removing it, we're deleting it, so it's the delete request. And finally, what method would be used to view a news article? You're not editing it, you're not removing it, you're not making a new entry. It is a GET request. Cool. Moving on to task 4. All right, HTTP status codes. So in the previous task, you learned that when an HTTP server responds, the first line always contains a status code informing the client of the outcome of their request and also potentially how to handle it. And these status codes can be broken down into 5 different ranges. 100 through 199 is information response. So these are sent to tell the client that the first part of their request has been accepted and they should continue sending the rest of their requests. These codes are no longer very common. All right. Next is the 200 through 299 range. This is a success. So this range of status codes is used to tell the client that their success was, or their request was successful. So that's fairly common if you have a good connection and everything's running. In our previous example, we did get that 200 status code back. 300 through 399 is redirection. So these are used to redirect the client's request to another resource. So it could be either through to a different web page or a different website altogether. We were talking in the previous lesson about DNS. Remember, there you can have subdomains that are redirecting or even domains that redirect to other domains. All right, so that could be the status code given for that initial request. 400 through 499 is client errors, so that's used to inform the client that there was an error in their request. I think we've all seen error 404 when dealing with websites. It's a client error. Then we have 500 through 599, which are server errors. So this is reserved for errors happening on the server side and usually indicate quite a major problem when the server was handling the request. As a normal end user, you won't see that very much, but if you are on the server side of things, it's probably more common than what you want in your daily life. All right, so common HTTP status code. So we have the ranges up here. Now we're getting into kind of the more common ones that you're actually going to be seeing. So 200 is okay. The request was completed successfully. 201, a resource has been created. So if you're doing a post request or something and it's making something, so hey, a new user was made, new blog post was made. So a resource has been created. 301, that's moved permanently. So this redirects the client's browser to a new web page or tells the search engines that the page has moved somewhere else and to look there instead. 302 is found, so it's similar to the permanent redirect, but it's only a temporary change. It might change again. 400 is bad requests. So this tells the browser that something was either wrong or missing in the request. This sometimes uses the web server resource that is being requested, expected a certain parameter that the client didn't send. 401 is not authorized, so you're not currently allowed to view this resource until you're authorized with the web application. So we'll see that with incorrect credentials, you put in your wrong password, something like that. 403, you do not have permission to view this resources whether you are logged in or not. So maybe it's an admin only page and you are not an admin. 405, the method is not allowed, so this resource does not allow this method request. For example, you get sent a GET request to the resource slash create account, and we was expecting a post request instead. All right. 404, I went over, page not found, this page resource that you requested does not exist. 500, internal service error, so the server has encountered some kind of error with your request and doesn't know how to handle it properly. 503 is a service unavailable, so the service cannot handle your request, as either it's overloaded or it's down for maintenance. All right, that was a lot. You don't have to remember every single one of these. All right, there's not a quiz here on all of this, but when you're dealing with HTTP, it's good to know common status codes, because that's what these are. These are common ones, and just be able to associate or just remember enough to Google it at a future time and saying, okay, that's why I got this. All right. So if you're getting like a 401 error, you're not thinking, oh no, the server's down. No, your account does not have the proper permissions to see it, to see what you're requesting. All right. So and then it says click on the view site button on the right and see what some HTTP status messages look like in a browser. So what is the response code you might receive if you create a new user or blog article? Okay, all right. So these are two different things. Okay, so it's showing what a 403 error looks like. So 403 forbidden, 404 is that not found, and a 503 error is service unavailable. So that's kind of what it looks like. All right. So answer the questions below. What response code might you receive if you create a new user or blog article? All right, so if we remember these, so we successfully created something, so it's probably gonna be in the 200s. We learned about two different 200 ones, so it could be an OK, where it was successfully created, or the request was successfully completed, or 201, where a resource has been created. All right, so we're talking about a new user, blog post, article. It's probably gonna be 201. Now, what response code might you receive if you try to access a page that doesn't exist? All right, so if we're talking about something that doesn't exist, that's not necessarily a server error because the client is the one who's trying to request that. So we're going to go into the 400s. Now, it could be a bad request. It could be not authorized. No, it won't be not authorized. I'm sorry. Could potentially be a bad request because maybe it was missing something, but most likely, more than not, we're talking about specifically we're trying to access a page and that page was not found, and that is going to be that 404. All right. So what response code might you receive if the web server cannot access its database and the application crashes? All right. We're talking about the web server here, not the client. So we're in 500s. And it's either going to be an internal service error or a service unavailable error. So remember, the internal service error is when the server cannot properly deal with your request. All right, maybe it's misformatted, something like that. But a 503 error is saying it's either down for maintenance overload or it just can't get what service. So maybe it can't access its database. Maybe it's down for routine maintenance. It's 2 a.m. on the weekend, something like that. And the team is doing, monthly maintenance, something of that sort. All right. And what response code might you receive if you try to edit your profile without logging in first? All right. So you're trying to edit your own profile, but you did not log in first. So we're going to go into the 400s and we're going to look through these. And this is the one that deals with authorization, which is the 401 error, because then you're not authorized. So it's not that you put in a wrong username and password, it's just you forgot to put in your username and password. So that's going to be 401. Alrighty, we have 3 more tasks in this room. We are now into headers. So headers are additional bits of data that you can send to the web server when making requests. Although no headers are strictly required when making an HTTP request, you'll find it difficult to view a website properly without them. So your common request headers. So these are some headers that are sent from the client using your browser to the server. A host. So some web servers host multiple websites. So by providing the host headers, you can tell it which one you require. Otherwise, you just see the default website for the server. User agent. So this is your browser software and version number, telling the web server which browser software helps it format the website properly for your browser, and also some elements of HTML, JavaScript, and CSS are only available in certain browsers. So the user agent, nowadays, when designing websites, we not only have a normal desktop where the monitor resolution, you can expect it to be a certain type of aspect ratio and everything like that, but some people might have wide format monitors. So how do you want your website to look when someone has a wide monitor? Okay, now how is it supposed to look on a mobile phone? How is it supposed to look on a tablet? These are things that designers have to take into account when designing, and devices sending their user agent in their headers help that, because then it can identify, okay, the person's screen is only this big. We're not going to have a paragraph shoot off of their screen. No, we're going to format it according to such. And that's just one example. There's other stuff that's definitely being parsed from there. But content length. So when sending data to a web server, such as in a form, the content length tells the web server how much data to expect in the web request. This way, the server can ensure it's not missing any data. We have accept coding, which tells the web server what type of compression methods the browser supports so the data can be made smaller for transmitting over the internet. We have cookies, which is the data sent to the server to rem, uh, help remember your information. And we'll go more into that in the next class. And then we have common response headers. So we just went over common request headers. These are common response headers. So this is returned to the client from the server after the initial request or after each request. Set cookie. So information is stored what gets sent back to the web server on each request. The cache control, how long to store the content of the response in your browser's cache before it requests it again. The content type, so what type of data is being returned. It could be HTML, CSS, JavaScript, images, PDF, video. Um, that just helps your browser parse the information correctly. And content encoding, so what method has been used to compress the data to make it smaller when sending it over the internet. So again, that was a decent amount of information. You absorb it as best as you can. You don't need to know every single thing. We're still in the pre-security module. We're building up the foundation, and we'll revisit these later, along with the rooms that go a little bit more in detail, and you get to do more hands-on stuff to see how this knowledge can be used in cybersecurity. All right, so we're still just building up those blocks. All right, so what header tells the web server what browser is being used? All right, so if we look at our headers over here, won't be host, user agent. Hey, this is your browser software and version number. So let's go with user agent. Don't forget that tag. Boop. Let's go ahead and submit. Hopefully it goes. Hopefully it goes. All right, that's taking a while. There we go. All right, user agent. What header tells the browser what type of data is being returned. Alrighty. So if we look, so it's telling the browser which type of data is being returned. So that's coming from the server. And it's not about cookies. It's not how long to keep that. It is the content type. All right. Because that tells the client what type of data is being returned, so the browser knows how to process it. And what header tells the web server which website is being requested. All right, so there's a good amount of information. It is going to be a request header, and it is the first one that we went over, which is the host. All right, because some web servers have multiple websites, so you want to tell it which one you actually want to be filled. Whew. All right, going into cookies now. It's already going to start off funny. You probably heard of cookies before. They're just small piece of data that's stored in your computer. Cookies are saved when you receive a set cookie header from a web server. Then every further request you make, you'll send the cookie back to the web server. excuse me, because HTTP is stateless and it doesn't keep track of your previous requests, cookies can be used to help remind the web server of who you are, some personal settings for the website, and whether you've been to the website before. So let's take a look at this example as an HTTP request. All right. So I have this one up here. It's a GET request. HTTP 1.1, the host is cookies.thm and the user agent is XXX. So the client requests the web page from cookies.thm. Then it gets this response. So it's showing, hey, we got that 200 status code, so we're looking good. Gives us information on the server, the date, the content type. It's going to be sending HTML back, and it's going to have that little break right there, and it will send the data. So the server responds back with a simple web page with a form asking for the user's name. So then we are going to send this request, which is a post request now. We have the host, user agent, the content type. It's going to be this application, URL encoded, and we're telling it it's going to be a length of 9. So that's how much you should be expecting, web server. All right, expect the data to have 9 characters. So name equals Adam. So we're telling it, hey, my name is Adam. So the client sends back the form with the name, and it is set to Adam. Cool. So the server says, all right, cool. We liked it, got that 200 status code. We're going to set a cookie now with your name equals Adam. All right. So the server responds with a set cookie header telling the client to save the data name equals Adam. Then we have a GET request on each and every further request of that session. In the header, we'll have the cookie name equals Adam as the client going over. All right. And then the server can see the cookie and display data. So because now on this web server, the form saying, hey, what's your name? It's been filled out. It sees that in the header from the cookie request now when it receives it, and it's going to display a welcome message instead of welcome back, Adam, because now there's a cookie that has been established, and that cookie contains the data of the person's name for the session of Adam. All right. Then let's go into cookies can be used for many purposes, but they are most commonly used for website authentication. The cookie value won't usually be a clear text string where you can see the password, but a token, which is a unique secret code that isn't humanly guessable. Then we can go ahead and view our cookies, so you can easily view what cookies in your browser, what what cookies your browser is sending to a website by using developer tools in your browser. And if you're not sure how to get to your developer tools in your browser, click on View Site button at the top of this task for a how-to guide. And once you have developer tools open, you click on the Network tab. This tab will show you a list of all the resources your browser has requested. You can click on each one to receive a detailed breakdown of the request response. If your browser sent a cookie, you will see it on the Cookie tab. So let's go ahead and View Site. Now this is dependent on your browser. So we have Firefox, Chrome, Safari, Edge, and Internet Explorer. Right now I'm using Edge. All right, so to get to developer tools, I'll click on the little triple dots here, this ellipsis. You can't see them over here, and we're going to more tools, and we're going to developer tools. All right, so now we have this little pop out. We're going to click on the network tab. All right, and that's how we can get to that. And we want to see if there will be anything that says cookies. Hey, what do you know? Here's a cookie right here. So this, boom, user match, some other stuff, and of course, it is not in plain text English for us to be understanding. That is going along with what we just went over, such as tokens and other stuff to help make it not so easily readable. So we can look. Some of these, this is an option. Let's see if we can find, this is a post request. Let's look at this. This is options, post. So yeah, so digging in and seeing what's actually going on is pretty fun. Um, it's kind of the back end of what's going on and being able to see stuff. So the access control allow methods, get, post, put, delete options. So cool. In your browser, go ahead, see what yours looks like, and get familiar with how to actually open up developer tools in your selected browser. Um, let's go into the question, which header is used to save cookies to your computer? And that we went over at the very like second second sentence here, which is set cookie. All right, so set cookie, boom, and that's you also saw it in this graphic as well. All right, so cool. We are on to task 7, which says click the view site button on the right. This is an emulator for making demo HTTP requests. Using what you've learned from the above tasks, you can complete all these answers. So we click on it. Tour guide. Would you like to get a guided tour to learn more about? Sure, let's go ahead and start this. So we can change our HTTP methods here, our request methods. Our URL we can change. We can send a request using the go button, and we can change parameters where you update our get and post parameters here. Alrighty, so the first question, make a get request to /room. So let's go and hit go. There we go. It is case sensitive, so just letting you guys know. So we went, said get request to /room. We got that response. So here's our request. If we look, we have our host, our user agent. We're using that Firefox version 87. Content length is 0 right now. Then our response, we got that 200 OK status. It's telling us about the server, the date, the content type. It's sending us text and HTML. The content length is going to be 252 when it was last modified. And now we have that break and our HTML that we were expecting as text. So we go through welcome to the room page. And we have our flag right here. And then in the browser, this is what would actually be displayed in HTML right here, which is welcome to the room page and our flag. So we can go ahead and hit submit. Next, make a get request to /blog. Blog using the gear icon, set the parameter ID. So set the ID parameter to 1. Then we're going to hit save. We're going to hit proceed. So we change our get requests to the appropriate place in blog. And we are saying, hey, give us the first ID, what's in there. And what do you know? We're viewing the first blog article 1, and we now have a flag. So we can go ahead and hit submit there. Then it's saying make a delete request to user/1. And we're going to get rid of this parameter that we established earlier because we don't need to send that with this request. All right, so in this one, this is how it's going to look. It's a delete request for /user/1. We're going to go ahead and hit go, and that's going to send it. Again, 200 OK, we're doing well, and the user has been deleted, and we got another flag. Cool. Now it's asking to make a put request to user 2. So let's go into put. We're going to change this to 2. And it's telling us to adjust the parameter of username to admin. We're going to go ahead and save and hit proceed. So this is put request. And here we go. Our username changed to admin. Whoop. Sweet. We're going to go ahead and submit that. And then post the username of THM and password of let me in to /login. So we're going to act like we're at a login screen. Boom. We want to post this, and we're going to change these values. Username is going to be THM for TryHackMe. Oh, whoops. So username, THM, we're going to save it. And password, so we want the field to be password and let me in. I didn't save. Boop. We're going to go ahead and post that. And what do you know? Let's go and hit go. And you logged in. Welcome back. Here is our final flag right there. Now, all those were 200s. So all the responses we got were 200s. I'm not sure if you go ahead and change this. Okay. Would it then result in an error? I'm going to go back and check that really quick, but If you want to stick around for that, cool. If not, thank you for watching. This is a little bit of a longer video, but congratulations on completing your HTTP in detail room. Hopefully you grasp all the concepts that we went over. If not, don't worry. There will be more rooms where we're going to dive a little bit deeper on that. All right. So let me go ahead and, oh, I got a little thing. All right. No, let me close you. Go back here. All right. Here we go. And I'm going to change the password really quick to, I'm going to say password is YARP. And I'm going to hit proceed. I'm going to send this. And there we go. So when we do that, instead for the 200 successful, we get that response of 401. So that is what we were expecting to see there, which is the 401 unauthorized status. So that's cool that their little simulator thing did that, their emulator. Happy to see that. That's about it. So I'll see you guys in the next room. Thank you all for watching. Good job, everybody.